Hey guys, hope you're doing well. Just before I start this video, I just want to say congratulations on finishing SPECH this year. It's been a pretty tough year, but hopefully you're happy with how you went, and I hope you'll get the scores that you deserve. Remember that everything is all relative, and that if the exam is harder or easier, generally that's going to affect the cutoff scores. Okay. Now, in general, with this exam, I haven't actually heard too much. It only really finished an hour ago, but I think the general consensus is that this exam wasn't really too nice. Again, as always, I don't really know how hard or easy it is until I really do it. And also, just to preface as well, in terms of my perception, whether it's hard or easy, it's not necessarily going to be completely accurate, probably, because I'm not doing this in timed conditions or really strict conditions. And also, I'm not really sitting this under exam pressure as well. Okay, so I'm just going to go over the multiple choice, and I'll see how I go for this one. Okay, so let's make a start. Starting off with the first question, consider the following statement. Which of the following statements is the contrapositive of this statement? So, if in a contrapositive statement, remember that if we have two statements, P and Q, if we know that P implies Q, that also implies that not Q implies not P. Okay, that is the contrapositive. Okay, so from this statement, if it says my football team is playing badly, that's P. And not training enough is Q, okay, then you just have to turn it into this sort of statement here. Okay, so what's the opposite of not training enough? It's training enough, right? So in that sense, A is gone, B and D are gone, so it's C or E. Then the next statement is not P, right? Not P would be my football team playing good or not playing badly, right? So it's going to be C. Okay, E is fairly similar, but the opposite of playing badly does not necessarily relate to winning. Okay, question 6. We have this equation over here, and we want to find the values of A, B, and C. Okay, so for this particular question, what you could possibly try is you could do trial and error. Okay, you could expand this partial fraction over here. You can sub in those particular values of A, B, and C, and you can see if it gives us those particular asymptotes. Okay, so you would expand, and what you can do is you can just test out each of those values of A that's given in the answer options. So starting with A, in that sense, what can you see the asymptotes are? Well, it's definitely not 2x plus 1, so A is gone. Okay, now trying B. Okay, your asymptote is definitely 2x plus 1, and one of the asymptotes is x is equal to 1, but there's also another one. So for this one, I'm just going to place a question mark. Okay, but I'm predicting that the likely answer would be B. Okay, but of course, you just want to double check everything else just to make sure, because the more correct answer would definitely be if there's only those two particular asymptotes. Okay, and if we look at C over here, we do have the 2x minus 1 asymptote. So it's not 2x plus 1 actually, so C is gone. Okay, D, 2x plus 1, that's a tick. This time we don't have x equals 1, so that's gone. And so the last one that we have to try is this one. Okay, so that one's gone as well. So the only possible answer is B. Okay, question 3. In this particular interval, this graph has two x-intercepts when what? Now again, for this particular question, I would probably try trial and error. Okay, so we want to graph A secant x over the domain negative pi to x to pi. Okay, I've typed this in twice. Okay, so we have this particular graph over here, and that's when A is equal to 1. Right, as you can see, there are two x-intercepts when A is equal to 1, so let's rule out some options. B would be ruled out, C would be ruled out, D. So it looks like it's between E or A. So I guess what I would test out is maybe A first, if you know, values in between 0 and 1 work? So 0.5. Okay, well, that doesn't work. Probably E, but I obviously want to make sure as well. Okay, so just testing out some values bigger than 1, that has 2 intercepts, that also does. And what about values less than -1? Well, firstly, when it's -1, there's one intercept only, and if we try out, say, -2, you can see there it does have 2 intercepts, so it's E. Okay, if Z equals that, then 4A over 1 plus conjugate Z. Okay, this one's quite simple. You just type this into your CAS. So 4A, I should delete the variable A over here. And basically you just sub in 4A 1 plus conjugate Z. And that's specifically when Z is equal to -2A plus 1 plus 2A I. So -1 plus I, what's that in polar form? Well, it's root 2 cis 3 pi on 4, which is B. Okay, question 5. Real Z bigger than 0, imaginary Z bigger than 0, what's Z squared? Okay, so I'm going to let Z equal to A plus BI over here. Now, if conjugate Z equals 4, that tells you that A squared plus B squared equals 4. Okay, and also if we have this argument equal to negative pi over here, what that tells you is that the argument of Z, that's probably, that one's probably going to be negative pi on 3. Because remember the 3 there by the Marvis theorem, if you raise it to a power, you multiply the angle by that thing. So if you go backwards, you divide the angle by 3. Okay, so based on this, what I would sort of imply over here is that arg Z squared is equal to -2 pi on 3. Okay, and so from there, what you can do is you can just go through each of these options over here, okay, and see if they do make sense. All right, so let's think about this for a second. If the argument is negative pi on 3, and if we're going this way, so that's also pi on 3, so I'm going to get a bit of negative here, both angles are pi on 3. Well, what do you notice, right? This is Z. Z conjugate would probably be this, because remember Z conjugate is just a reflection of the x-axis. What I can notice from there is that, in fact, if we want to go from Z conjugate to this thing, perhaps that thing over there, I would imagine, it could possibly be just negative Z conjugate. Because all we're really doing over here is we're actually just rotating 180, which is just multiplying by I squared. It's not exactly Z conjugate though, okay? It depends on the magnitude as well. So based on the answers, it's probably either B or E. And that is where this bit of information comes in. Conjugate Z equals 4. Okay, now if conjugate Z equals 4, right, what does that actually mean about the conjugate of Z squared? Well, if you think about it, right, what that sort of implies is that when you take the modulus of the square number, right, then firstly, if you think about the polar form, let's say we let Z equal R cis theta, then what we're actually doing is we're taking R squared cis theta, like that. In fact, we know what the magnitude is. We know it's 4. Okay, so in that sense, if you think about it, the magnitude would actually be 16. So it would be E. Okay, Euler's method, it looks like, for the pseudocode, quite nice. Okay, now is there anything different that I notice about this pseudocode? Not really. It looks like a very standard Euler's method problem, just written in pseudocode. There's nothing really that looks different about the way this pseudocode is set up. Okay, so what I'm going to do is I'm going to set up the Euler equation. I'm just going to type in this function over here, and I'm just going to see how many iterations it takes me to get to whatever number that's being provided. Okay, so what do you need to type in? So your initial x value, which is 0. Sorry, you go 0 to, what do we want to go to? Let's say 2. Okay, I'm not entirely sure how many iterations we'll need here. The step size is 0.5, and your y value, your initial value, is 0. Okay, why is this not working? Okay, 0 to 2, 0.50. Oh, sorry, it's the other way around. Yep, there we go. Okay, so we have all of this, right? Well, that's one iteration, right? That's 2 iterations, and then I would imagine this is your 3rd iteration, so maybe C. Okay, but I'm just going to quickly read this just to double check that I'm not going crazy over here. So that would be 1 iteration going to 0.5. Then it would be 2 iterations, and then it would be 3. Okay, so I do think it would be, should be C. Yep, okay. Yeah, it would be C, because each iteration, you're printing out the new value of y, which would be this, this, and then this. You're not printing out the original, so it's 3, because I think the other alternative is maybe it could be 4, but I do think it's 3 based on the pseudocode that's been given. Okay, question 7. So we have a differential equation over here. The value of y on the same solution curve on x is 1.5. So for this one over here, what I would do is I would just try and sketch a solution curve and then see what sort of value it looks roughly to be. So the solution curve is x -1 and y is 2, so it would be over here. And then you want to try and sketch as much as you possibly can on this. Okay, I don't exactly know how it will turn out, but I'll give it my best shot. So probably maybe something like this. Okay, not the best curve ever, but let's see what the solutions say. So the value of y on the same solution curve when x is 1.5, so about here, is closest to what? Okay, so at least the good thing about this is we can rule out a bunch of options. So it's definitely not A, it's not B, it's not C. It looks to me like it's probably going to be D. Okay, as long as I haven't stuffed anything up. Okay, question 8. So we've got a spar pool over here. It's your typical tank problem. So remember that with tank problems over here, it's rate in minus rate out. So what's the rate going in? The rate going in, is there even a rate going in? Yes. 20 liters of well-mixed spar water. That's your rate in. Sorry, that's rate out actually. No, there is no rate in. Okay, so there's only a rate out component. That's it. There's no rate in. So that bit is actually kind of gone, right? So in that sense, in your rate out would be dq on dv multiplied by dv on dt, and this is all out. For dv dt, that one's actually a very nice one because that one's just 15. But for dq dv, you've got to use mass over volume, right? So what are you exactly doing? Well, in terms of your mass, Q is the kilograms of chemical, and the kilos of chemical that you have would be Q, I think. And in terms of volume, right? Oh no, there is actually a rate in, but it's fresh water. Yes, there is actually a rate in. They just listed the rate out first. So there's a rate out and a rate in, but we still don't include the rate in because the rate in is just fresh water. Okay, so there's actually no chemical going in per se, right? Okay, so with that, it's just Q, right? Q over, what's the initial volume? Well, it's 8,000, and then plus the thing going in minus the thing going out times T. That's it. And I should move this as well. 15 across. Okay, So if we do simplify this down, it's 15q, negative 15q on 8,000 minus 5t. Okay, and we can cancel the 15. You can cancel it with 5, so you get 3q. 8,000 divided by 5 is 16,000. Hopefully there's an option for this one. Okay, you can also bring the negative down and it becomes t minus 16,000. So it looks like it's going to be c. Okay, question 5. We have a set of parametric equations. We want to find the slope of the tangent when t equals 2. So for the tangent, firstly, we've got dy dx equal to dx dt multiplied by, or you should just do dx, sorry, it should be dy dt divided by dx dt. That's the formula you want to use there. So on your calculator, all you really have to do over here is you've got two things. You've got your derivative of your y thing. So negative 8 over t squared plus 4. And you've also got your derivative of the x term, which is 6t on t plus 1. And then it wants it at t equals 2, so that's 3/4. This question, this one looks like integration by parts. If in equals blah blah blah, in equals 1. Okay. So for all of these, you probably just want to, if you look at the answers as well, each of these answers do have in minus 1, so you might want to actually calculate what that is. In minus 1. I think that would be beneficial over there. Right, so for in minus 1, right, in minus 1 would be just subbing in n minus 1 into here. And yeah, I don't know what that will give me, but you know, we can always test them out. And in fact, if you don't really know, I think actually probably the more efficient way of doing this particular question is probably just to, I might even actually think about trial and error here, to be honest. I think that's a bit easier. No, actually, you could actually use, you could use integration by parts actually, because if you do want to evaluate this integral, it would be equal to this minus, because we'll just say this is dash over here, okay, and then from there we can do this. No, actually we shouldn't do that, that's not very good, because we're not going to get what we want over here. Oh, no, hang on, I know a better way actually. For this over here, what we can actually do is we can diff the e to the x in the original thing. So like that, that's I to the n, right? If we do the diff over here, right, we're going to get the integral of this minus the derivative of the other thing, right, of this guy. So that derivative is going to be n times 1 minus x, n minus 1, and the negative goes in front as well. Okay, so what is that thing equal to, this guy over here? Well, it's equal to 1 minus x to the n times e minus e to the 0, which is 1. Okay, and that thing over there, that looks almost like I to the n minus 1. The only exception is that there's an n in front and there's a negative. These two negatives combine to make a positive anyway. So that would be plus n I n minus 1. Does that look familiar to any of these answer options? Yes. Oh, it actually does it. Actually, I don't know what I'm doing here. For this option over here, this part, I forgot to sub in 0 into here, sorry, and 1. So in the first instance, if you sub in 1, obviously that's 0. If you sub in 0, this becomes 1, and then e to the 0 is obviously 1. So actually this last bit is just negative 1. Okay, so looks like it's A. 11. the area of the curved surface is equal to what? So for this one, you shouldn't bother putting it into your CAS. Just write down the equation, see what it is. And also, with this over here, keep in mind, you should look at where it's being rotated around. It's the y-axis. So the integral is 2 pi. With the y-axis, you want to use the y-coordinates. So it's from 0 to pi and 2. And you also want to use x over here. Okay, and then it's 1 plus dy dx squared, I believe, and it's dy. No, it should be dx dy actually. Okay, cool. So what is x? Well, x is cos y. And this square root, well, if x is cos y, then dx dy is negative sine y. So the inside is 1 plus sine squared y. Okay, does that correspond to anything? So looking at what we have over here, it's not A, it's not B, it's not C either. So we're left with D or E. It's a U sub, right? So the U sub that's being made, what's the difference? The difference is one of them just hasn't changed the terminal. So I think it's very likely that the answer is E. Yeah, that looks right to me. It's just subbing in sine Y. Yes, okay. This question over here, the acceleration is described by this equation. The velocity after this many seconds is what? So for this one, if it's mentioning seconds, that means you want to use dv dt because you want to get an equation in terms of t over here, right? So when you integrate this, it becomes 1 over 1 plus v dv, and then dt, and then you also want to integrate it. But if we do have initial conditions, we also should put them in. The initial condition is, if it starts from rest, that implies that the velocity is 0 and the time is 0. That's your initial condition. And your condition that you care about is log e plus 1 on top, and then your t, you just leave it as t. If you do this, you don't have to really care about it here, but generally you should dummy variable if you're doing this in extended response. Okay, so you just type this in, see what you get. Okay, and you want to solve for v. So solve this equation for v. Hang on. No, I've put it in the wrong place, you stupid bastard. Don't know what I was doing. That should be in t. Yep, okay, my bad. So scrap this. Should be here. Okay, and this is where you dummy variable this one. Okay, so velocity from there is negative e minus 2, or it's something else is e. So the only possible one, I think, is A. Okay, question 3. A tourist in the hot air balloon drops, the phone is 80 meters above the ground. Assuming air resistance is negligible, how long in seconds does it take to reach the ground? So firstly, acceleration is negative g. Okay, what else do you know? You also know the initial velocity. So the initial velocity is 2.5. You also know the distance as well. It's 80. So you actually want it to be negative 80 because you want to drop the phone down, right? It's going downwards. Okay, so what do you need to find? You want to find the time, right? That's what you don't know. So what's the formula that connects the two? Well, the one that I can think of off the top of my head is x equals ut plus a half at squared. Sub in those particular numbers and you should be able to get your value of t. So solve negative 80 equals 2.5 times t plus a half times negative g, which is 9.8, or I'll put negative 9.8, multiplied by t squared, and we solve for t. What's that roughly? It's about 4.30, which is e. Okay, question 14, we've got three vectors. Magnitude of c dot n is equal to 1. So if it says a dot n is 0 and b dot n is 0, you would imagine that it's just looking for the cross product of a and b. So the cross product of 1, 1, 0 and and also 1, negative 1, 0. So that's going to be your n. And the unit vector of n, that's going to be 1 on 2. So 0, 0, negative 2. Yeah, so that's going to be your unit vector. And if you're dot producting that with c, you can take the dot product of 1, 2, 3, and also 0, 0, negative 1. You want to find the magnitude of that, so it's the norm. Okay, and so dot product. Okay, it's negative 3. The magnitude is, well, actually the magnitude is quite easy, it's just 3. Okay, 15. If the sum of two unit vectors is a unit vector, the magnitude of the difference of the two vectors is what? So this question is quite hard to think about unless you use an example, okay? Maybe you might want to just pick any random two unit vectors that you can think of, right? So maybe one I can think of is, firstly I'll just write down trial and error. Because if you can just pick one example over here, then you probably can do this particular question. Okay, so the sum of two unit vectors is a unit vector. Okay, so how can we make this be the case? Well, I guess what we could do, maybe we could make it like this. So 1 over square root 2, 1 on square root 2, 0. That could be one unit vector. Another unit vector, I'm thinking we could cancel out one of the terms here. And we could just add another 1 over square root 2, perhaps, like that. Because if we add these two vectors, the x components cancel, and if we add these two, we still get root 2 on 2 and root 2 on 2, right? That will give us a unit vector. So what we need to do, now you just take the difference of these two, and see what the magnitude is. Okay, so root 3. Okay, 16, we have a vector over here, position vector. The total vertical distance the ball travels before it hits the ground is what? So basically, we have a position vector, I is east, j is north, and k is up. So the particular part that we really care about is this one. Okay, so the total vertical distance it travels before it hits the ground is what? So basically for this, firstly, you probably want to actually find, when it hits the ground. I think that's quite important. So to find when it hits the ground, you just solve that equals 0, quite simple. Okay, so it's all of those things. I'll just round it because I'm a bit lazy. So we have basically t equals that thing. Okay, so perhaps what you do want to find over here is if you want to find the total vertical distance, another thing that might be useful to find is actually the turning point. So we can complete the square of this thing to find where the turning point is. Okay, so it's at this coordinate over here. Okay, and so if you think about it, we could also sub in 0 in this expression to find out where initially it is. Okay, so basically the path of the thing, if you just think about k, it starts at 3 on 2, then it goes up to 636 on 49, then it goes back down to 0. That's sort of the main idea. Okay, so in that sense, right, if you want to find the total distance, it's just going to be this minus this for the upwards component and then plus this for the downwards component. So what is that roughly? That's roughly 24.5, which is D. Okay, 17. Consider these vectors. If A cross B equals C, then what is that? So again, for this particular question, you probably just want to, you might want to think about trial and error. I won't do it trial and error the first go, but I will obviously just judge later to see if trial and error is necessary. Okay, but if you do cross product these two, you're going to get these things, okay? Now, if you do, actually, you don't need to trial and error, because what you can do is you can just directly solve these vectors. So 2, -7, and y, and you can solve for A, B, and y. Okay, so 1, -2, and -5, so that's C. Okay, question 18. For what value will make the following planes perpendicular? So if they are perpendicular, then we expect the normal vectors, the dot products, to be 0. Okay, so what are the normal vectors? Well, the normal vectors are, and I'm a bit lazy, but you should write these as vectors, -2k3 and 2k3, -2. You just read off the coefficients of the planes. So all you need to do is you just solve for the dot product of 2 -k3 and 2k3 -2 equals 0. Solve for k equals 6. Okay, nearly done. 19. Normally distributed with mean of 800 and standard deviation 200. What's the probability that in a random sample of 16 unpaid invoices, the total amount owed is more than that? Okay, so for this particular question over here, total amount owed is not actually, it's not actually the sample mean. It's actually x1 plus x2 plus all the way to x16. Okay, now the expected value of that thing is just going to be 16ex. Okay, the variance is also the same. And so what that means about the standard deviation, particularly, is that if we square root the variance, right, it's actually going to be 4 times the standard deviation of the original. Okay, because the square root of the variance of standard deviation, you square root 16, that's equal to 4. Okay, so in that sense, right, we can just use norm CDF here, because all we're doing is we're just going from 13,500 to infinity, and the mean is 16 times the original, and the standard deviation is 4 times the original. Okay, so it's that number. Looks like it's B. Question 20. Okay, we have a 99% confidence interval, and we want to find what the standard deviation is. Okay, so what you can do is, in a 99% confidence interval, you can find x bar, because x bar is just the average of those two things. Okay, so you can take the average. It's actually just the middle of the two bounds, and that would be your x bar, so it's that. And what you can do is you can basically just take the margin of error, so the margin of error is that minus that, and that's going to be equal to basically your other part, so it's z times the standard deviation over root n. What's z? Z, based on 99% confidence interval, it's about 2.5, I think 5.8 actually. 2.58. N in this case is 100, and you just solve for standard deviation. Here, it doesn't really matter what the exact value of z is, because if you look at the answer options, they're all pretty far apart. I don't think changing it to the exact value would make a huge difference based on what I can see. So anyway, take this equation and you solve for standard deviation. Square root 100, solve for theta. So if you do that, looks like it's around A. Okay, What I'm going to quickly do is, because it's not very close actually, I'm going to verify this using inverse normal, just to 100% make sure, because I'm just not entirely sure at the moment. Okay, so that is your Z value. If we plug that in, do we get anything drastically different? Let's see. Okay, it looks closer. Yes, so it's definitely A. Alright, so don't think that MCQ was too hard. Seems a little time consuming, but yeah, lots of interesting questions. Definitely a lot of new questions this year that haven't come up before. So hopefully it went okay. I hope these solutions are correct. Let me know if I did stuff anything up, and I will be back with the extended response soon. Bye.